Hello, everyone, and welcome to today's event in the Certara University Express webinar series. The topic for today will be quick and easy steady-state simulations in Phoenix. My name is Christopher Mell, and I'm a senior instructor at Certara University, and I'll be your presenter for today. We're also joined by our panelist, Tom Jones, and our event host from marketing. I just want to talk a little bit about how this webinar is set up. So everyone is muted on audio by default. This will be a 30-minute webinar with a 5-minute Q&A session. So on the right-hand side of your WebEx, there's a Q&A area where you can type any type of question you might have, and we will take time to address those in the 5-minute session at the end. So to give an overview of what we'll talk about today, so doing simulations in the Phoenix software. The underlying assumption here is that good PK parameter estimates are available from either modeling single-dose data or from the literature. And we'll talk about how to set up an input data file for simulations. We will introduce the Phoenix model object, talk about a feature of the Phoenix model object called ADDL, that allows one to input additional doses for the simulation. We'll talk about how to specify the simulation mode in Phoenix. At that point, I will perform a software demonstration of 2 different example simulations, and we'll get a chance to look at all of the results and then wrap up with our Q&A session. So probably the biggest challenge for new users of Phoenix, or maybe if you haven't run a simulation before, is understanding some of the terminology. So I'd like to go through some of that here at this time. So in the context of the simulations, the time, of course, is important. It's time of observations, predicted points. But if you're making a simulation input data set, the times you're going to want to put in are the times of dose administration. Also, when you're using the Phoenix model object, you see some required columns that start with a capital A. The capital A stands for amount, and it could be AA, which stands for amount in the absorption compartment, or A1, which is amount of drug in the central compartment. So essentially, these are referring to amounts of a drug being administered. The ADDL, it stands for the number of additional doses administered after the first dose. So essentially, you're setting up a dosing cycle where you have an initial dose administered, and then you're tabulating how many additional doses are required to complete the cycle. Another column that's often used is this II column. That stands for input interval, and that corresponds to the length of one dosing cycle. If you're doing more than one type of dosing cycle, it might be important to make use of a regimen column. In this case, in the example I'll present, this is an abbreviation of the dosing cycle used for sorting purposes. So for example, QD, BID, TID, weekly, or whatever type of regimen abbreviation you want to use. In terms of the outputs, our Y variable, our C obs is going to be observed concentrations, and then a capital C all by itself are predicted concentrations. If you're using PD data, these are abbreviated as EOBS and E, respectively. Okay, so for the input file structure for simulations, the required columns to run a simulation with multiple doses are time, a column with the dose amount, and an ADDL column. Optional columns that you may want to avail yourself of are regimen, COBS, EOBS, and the II column. So here's an example input file to simulate PK concentrations after multiple dosing with 3 different regimens. So we have a regimen column here that identifies how many doses per day, a time column that identifies when the dosing events occur, a dose column that records the dose amount, ADDL, in this case it's listed as 9 for all of these, so each of these rows has 9 additional doses administered. And then lastly, we have our input interval, which is 24 hours. I'd like to talk briefly about the Phoenix model object, which is the tool we're going to use to do our simulations. The Phoenix model object can be added using the Insert menu at the top of Phoenix, and also starting from the input data set, right-clicking and selecting Send to Phoenix Modeling, and then Phoenix Model. On the Phoenix model, there's a structure tab at the bottom that allows you to first identify the type. Is it PK, PD, PK-PD, indirect response, and so on. We'll be focusing on PK for today. The parameterization, clearance, rate constants, or macro constants. The type, the route of administration. In this example, it's intravenous. And the number of PK compartments, which is 2 compartment. There are a variety of other options here that you can check on and off to set up the structural model. Once the structural model is defined, there's a setup panel at the top of the Phoenix model object wherein we read the input data set, and then the panel over to the right is used to assign columns to data types. So, of course, we have our time column. We might have an observed concentration column. If we have multiple subjects or multiple profiles, we might use a sort column. And then typically we map the dose amount to this capital A column. In this case, since it's intravenous, it's to the A1 column. On the bottom panel, returning to the bottom panel, there's a parameters tab, and below that a fixed effects sub-tab where you can enter initial estimates for the PK parameters. So if this is a 2-compartment model with 2 volumes and 2 clearances, the values for those parameters are shown here. So if you were doing fitting, these would be initial estimates. In the context of simulation, these are actually fixed as constants when running simulations. So it's very important to have confident values for these parameters to run a good simulation. The Input Options tab allows you to set up a repetitive dosing cycle using the ADDL feature. So here we are in the Input Options tab. We check ADDL. An ADDL submenu appears where you can specify the cycle time, whether it be a constant value that's typed in or read from an input column. The dose point, which is where the dose enters the system, so that would be compartment A1 in this case. And then the amount, which is either a constant that you can type or can be read in from a column. Lastly, the Run Options tab is where you can set up that simulation mode is being used. So it's important to make sure to set that. And from there, you can specify the number of output points you want, the time range. So the dosing time is the start time of the simulation, and then how far out do you go from there is where you enter this number here. The Y variable, if you want predicted concentrations, just type in capital C, which is the Phoenix notation for predicted concentrations. And you can also, if desired, set up simulation tables. For example, if you want to use a sequence statement, you can do sequence and then in parentheses the start time, which is 0, end time 120, and then interval between, which is 1. So this statement, as listed here, would run a simulation every hour from time 0 to time 120. And then our output predicted variable is going to be C. Okay. Once the simulation is run, output plots are produced. And so you get an output spreadsheet of predicted times and concentrations, which is shown on the left here. And then the plot output will show the multiple dose simulation. So that's our endpoint. Okay, so I have a couple of examples I'd like to show you in the Phoenix software. The first example, so just a background, let's say a chronic pain relief medication is being studied, and at high concentrations there's a risk of side effects due to toxicity. A PK scientist wants to predict the steady state profiles for 3 different regimens of the same total daily dosage by QD, BID, or TID. Single dose PK data is not available. However, according to the literature, the drug follows a 1-compartment model with typical values for the PK parameters Ka, 1.2 per hour, volume of distribution, 300 milliliters, and a clearance of 20 milliliters per hour. So in the Phoenix model object, the ADDL option will be used to perform multiple dose simulations for these 3 regimens. So that's the first example. So I'd like to go ahead and share my Phoenix application. And I'll just go ahead and ask our panelists if Phoenix is visible.
Yes, it is.
Perfect, thanks. Okay, so since we don't have a PK model per se here, I'm going to take the PK parameters from literature, and I'm going to start by making a simulation input data set. So I'm over in the left panel of Phoenix, and I'm going to go ahead and right-click on the Data subfolder, and then select New, and then select Worksheet. And I'll call this my worksheet. I'll just call it 3 regimen sim. Okay. And I'm going to start in the bottom panel adding columns. So I want to add a text column, and I'm going to call this regimen. And I'm going to start filling out the spreadsheet here. So for QD, I only have 1 dose administration, so I'll type QD once, press enter. And then for BID, there's actually 2 doses. So I'm going to type BID twice, and then TID 3 times. So what this is going to do is just basically fill in the spreadsheet vertically here. So as I add other columns, I can just fill in a completed spreadsheet. The next column I'll add is time. So this will be a numeric column. Type in time. And in this panel here, specify units, which is HR. And for QD, that's going to be times 0, BID times 0 and 8, actually 0 and 12. And TID times 0, 8, and 16. And at this point, I'll go ahead and add a dose column. So here we have dose, and I'll set the unit to microgram. For the QD regimen, it will be 6,000 micrograms. BID, 2 administrations of 3,000 microgram each. And then for TID, 2,000 per dose. Next, to set up a multiple dose simulation, let's say I want to simulate 5 total doses. What I'll do is add a column named ADDL. And since I've already got the initial dose administration, I'm going to specify that there are 4 additional doses being administered. And then lastly, I'll make use of a column to identify the dosing cycle length for each of these doses. So I'll use the II notation here and put in the cycle time, which is 24 for each of these doses, 24 hour. And the cycle time is in the same units as the column that you map as time. So now that the input data set is set up, I'm going to go ahead and send it to a Phoenix model object. So I'm right-clicking in the object browser here and selecting Send to Phoenix Modeling, and then Phoenix Model. And I've set up a couple of sub-workflows just to kind of keep the different examples separate. So I'm going to put it in this workflow named 1 compartment extravascular. And now that the model's been added, the first step I'm going to do is set up the structural model. So I'm just simulating the regimens with fixed values, so I don't need to run in population mode. I'm going to set the route of administration to extravascular, and then this is a 1 compartment model. The closed form is the integrated solution. If I uncheck closed form, I can view the model in differential equation mode. I'm going to go ahead and make that specification. And then in my object browser, I'll go ahead and rename the model 3 regimen sim. In the top panel, under Setup Main, we'll go ahead and sort by regimen. Time should map automatically since it's named exactly that in the input data set. And then I'm going to specify dose to the AA column. So this is where the dose input occurs. Okay. I'm not mapping an observed concentration column. In the bottom panel, there is this warnings that says optional main column C odds is not mapped. In the context of simulations, this is not important, but it's there to remind you. If you were doing a fitting, you would definitely want to map this. But in this case, we don't need it, so we can ignore this particular warning. And the structural model is set up. The columns are mapped so far. I'm going to go over to the Parameters tab, and then Fixed Effects sub-tab, and enter my values for the PK parameters. So these are 1.2 for Ka, 300 for volume, and 20 for clearance. Next, to specify the dosing cycles, I've gone to the Input Options tab, and I'll check ADDL. And over to the right, there's a panel. We'll go ahead and press Add. And then for my delta time, I want to set this to my column that I've set up called II, so that's the input interval. The dose point, where dose enters the system, is the absorption compartment, so that's AA. And then the amount is actually being read in from a column, and the column from my input data set is named dose. So I'm going to go ahead and type in dose as the name of my column that contains the amounts. Now, I'll go ahead to the Run Options tab, specify that this is a simulation, and then enter in a number of simulation points. I'll type in 1,000 with a maximum range of 144, and then set up my output variable, which is capital C. And then I'll go ahead and run the simulation by clicking the little green play arrow here. So that's the execute button in Phoenix 8.x. And so the simulation run has completed. And now I want to go ahead and look at the outputs here. Okay, and so I need to take a look at my output here. Okay. And
you want the individual simulation plot.
Yes, the output plot here is named individual simulation. So I'm going to go ahead and pop this out into a panel here, a pop-up window. And so for each regimen, the individual simulation plot, they're actually listed in alphabetical order. So BID is first, QD, and then TID. So we have output simulations. And if you wanted to, for example, put a reference line on here, let's say the question of interest is that you want to see if regimens exceed a certain toxic threshold. Let's say, for example, 20 micrograms per milliliter, there's a toxicity risk. Could set a reference line on the y-axis with a value of 20. And then I'll go ahead and assign a label here, which is toxicity risk, and toggle the position, which is below right. Okay. Okay. So this is the first simulation example. I'm going to go ahead and stop sharing the Phoenix application briefly here, and return to the slides. And the second example that I've prepared for today, so the background is a sedative for ongoing outpatient procedures, can be given by either IV bolus or infusion. The drug follows a two-compartment PK model, and single-dose data is available for 21 patients. A two-compartment PK model is fit to obtain individual PK parameter values. The objective here is to predict steady-state PK profiles for each of these patients following multiple dose administration. The simulation will be run using the Phoenix model object, and the ADDL option will be used to set up the dosing cycle, and the individual PK parameters will be read into setup parameters. So we're actually going to get individual simulations for each patient. Okay, so I'll go ahead and switch back to the Phoenix application. Okay. And in this case, in my second workflow, I've actually plotted the single dose data. So these are the PK plots. These are on a semi-log scale. We see that there was an IV bolus administration, and these are the PK profiles for the individual subjects. Okay, so this is what's actually been fitted. These data have been fitted in a model, and in this case, the predicted concentrations are the green lines, and the observed concentrations are the red circles in this case. So a PK, a two-compartmental model has been fit for each individual subject to this data. And there's also a theta worksheet that shows the individual PK parameter estimates for each subject. So the ID column are the subject IDs. This is a listing of the parameters in the model, 2 volumes and 2 clearances. and the final estimate. So let's say that we want to run a simulation based on this single dose model fitting. So what I'm going to do is take the original input data set that has the PK data, and we're going to go ahead and the ID column lists the subject ID, the times or the observed, the times for observed concentrations, which are DV. But what I need, remember from the slides that we need an ADDL column if we want to use that feature to do simulations. So what I'm going to do is send this data set to a data wizard and make an ADDL column that specifies the additional doses. So I'm taking the 2-compartment PK data, sending it to data and then data wizard. And I'll put that in the 2-compartment bolus workflow. And to make a new column, I'm going to use the transformation action, press add, and I'll set up a custom transform where the new column name is ADDL. And what I really want is the row that has time 0 in it to list the number of additional doses. So I'm going to use a formula here where I say if, in parentheses, time equals 0, put a 4 in the ADDL column, otherwise put in a 0, and then close parentheses. So since I use the word time here, in the top mapping panel, time automatically mapped, and I'll just simply execute this transformation. And so the result of the data wizard is a new worksheet that has all the original data plus an ADDL column that lists 4 additional doses at time 0, but no additional doses at all the other time points. Okay, so I'm going to rename this to with ADDL. And I'm going to return to my single dose fitting object, and I'm going to make a copy of it and use it for the simulation. So I'm going to go ahead and right-click on the fitted model, and then right-click on the 2-compartment workflow and paste it back in. And the new item is going to be a 2-compartment IV bolus simulation. Now, since I made a copy of the model, I have the original data set mapped here, and I don't want that. So above the mapping panel, I'm going to simply click the little X here to remove the source, and then use the open folder icon to find the data wizard result. So that's in this list here, data wizard result. I'll press OK. And at this point, I want to go to parameters. So remember that we wanted the individual PK parameters. So under the Setup tab, Parameters, I'm going to go ahead and browse for the 2-compartment fitting, and those parameters are listed in the Theta worksheet. So I'm selecting Theta, and I'll click OK. And I want to sort by ID, map parameter to parameter, and then estimate to initial. Okay, so those are the values for the individual PK parameters. And then under parameters.mapping, I'm going to click Rebuild, and there's a little pop-up window that allows you to match the columns from the input data set, which is Theta, to the actual parameter names in the model. So since I'm using exactly the same nomenclature for all the parameters, this checklist has populated automatically with the correct selections. So I'm simply reviewing in this case, but if you'd had a different model, you could check to match the parameters correctly. So I'm going to go ahead and press OK to this. And now I'm ready to go to the Input Options tab to set up the dosing cycle. So go to check the ADDL checkbox, press Add, and then enter in my, my times. So in the previous example, I mapped in columns. I'm just going to say that I want my delta time to be 72 hours. So I'm typing in a value of 72. My dose point is A1, which is the central compartment. It's a bolus, and then the amount is 50 units. And then lastly, I'll go to my Run Options tab, set the mode to simulation, and I'll again choose 1,000 points, In this case, I'll simulate out to 600 hours. And of course, I want C as my simulation variable. And at this point, I'll go ahead and run the simulation. And so in this little pop-up window, it actually tells you. So the top line shows 2-compartment IV bolus sim, and it says that it's in progress. So you'll know it's finished when that status changes from in progress to completed. There's also at the very bottom of the Phoenix application, there's a little status. So as it's going through its iterations here and processing, it will show you some updates. Okay, so my status is now changed to completed. I'll go ahead and close the little pop-up window here. And again, I want to show the individual simulation plot. I'm going to go ahead and double-click it to pop it out. And at this point, I can access the plot options at the bottom. So I'm going to go ahead and toggle my y-axis to logarithmic. And so each of these in this lattice plot shows individual subject simulations for the 5 doses. Okay. Okay, and I'd like to just go ahead and mention too, if you do want to change this from bolus to infusion, you could also do that simply on the Input Options tab. If you don't want a bolus, you simply press this button if you wanted to model an infusion, and let's say you wanted to do a rate. So I'll do a low rate of infusion so we can just see the profile, and I'm going to go ahead and just let this run so we could see an infusion. So at this point, we're coming up to a little less than 5 minutes left, so I'd like to open up for a Q&A session here. Do we have any Q&A coming through the chat?
Not yet, but one thing that you might want to address while we're waiting for questions to come in would be in your first simulation, you use the ADDL with multiple rows. You could have, you might want to point out that you could do that in one row. Why don't you show them the 3 regimen sim worksheet that you
yeah, so Tom, I'll return to that in just a moment. So, but I just wanted to point out that all I did to run this as an infusion instead of a bolus was toggle to infusion, and then I did a slow rate. But we see here clearly these are infusion input profiles. So it is very easy to change the route of administration in your simulations. Yeah, so back to the point you were making, you could do one row for each of these, but you would need to modify the number of additional doses in each row. So in other words, the way I have this set up with multiple rows here, I can set every one of the cycle times to 24, and then each of them has 4 additional doses. If I collapse the BID and TID to one row, I have to change the number of additional doses. So it's for example, for BID, I would need 8 additional doses. For TID, I'd need 12 additional doses. So I would just need to make sure to put all that information in, and then I would change the input interval to 8 hours for TID and 12 hours for BID. So there's a number of different ways you can set these up. But yeah, in this case, just use the approach of putting one entry on each row to keep that cycle time at 24 for all of them.
Okay, and now we do have some questions that have come in. The first one is there a difference between II and tau?
Yeah, so you could think of, so the II is the input interval time between doses, and you could think of it like your tau from steady state. So all that is the time between dose administrations. So they're equivalent. Yeah, you could use that name if you wanted to.
But in the input you have here, you have a cycle time of 24 hours, but tau would be 12, 24, 12, or 8. It
would be 12 for BID, and it would be 8 for TID.
So there is a difference here between II and tau because your tau is, you've set up the II always to be 24 hours, but the dosing interval is different depending on the regimen. The other questions have to do with whether the webinar will be available online, and yes, it will be. And also there's a request if we could upload the Phoenix projects in 8.0 format so that people who use either 8.0 or 8.1 could open them. So we'll have to we'll take that offline and decide whether we can do that. All right, I don't see any other questions.
Okay, so I'm going to briefly just return to the slides and mention a couple of items here. So we do have an upcoming Certara University Express webinar on June 12th. This will be tips on how to implement company policies in non-compartmental analysis. So my colleague Tom Jones will be presenting that on June 12th, so we hope to see you there. And of course, you can continue in the series at www.certarauniversity.com on our professional development track. We have both in-classroom and e-learning training available there at Certara University. So we do hope to see you register and avail yourself of all these learning opportunities. Okay, so we've reached our end time, so I'm going to go ahead and conclude the webinar. Thank you, everyone, for attending. And of course, we will capture all of your questions in the Q&A chat panel and address those in a forum post after the webinar is completed.
Yeah, and we picked up quite a few more, so we'll be addressing those.
Excellent. So thank you, everyone, for attending and posting your questions. This concludes the webinar. Have a good day.